Welcome to our video on the search for habitable exoplanets. An exoplanet, also known as an extrasolar planet, is a planet that orbits a star outside of our solar system. In the past few decades, scientists have discovered thousands of exoplanets, and the search for habitable exoplanets has become one of the most exciting and important areas of astronomy. But what makes a planet habitable? To be considered habitable, a planet must meet certain criteria. It must be located in the habitable zone of its star, where temperatures are not too hot or too cold for liquid water to exist. It must also have a solid surface and a stable atmosphere. The habitable zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for water to exist in liquid form. This is important because water is essential for life as we know it. Scientists use a variety of methods to detect exoplanets and study their properties. These include radial velocity, transit, and direct imaging. By analyzing the light from a star, scientists can detect the tiny wobbles caused by an exoplanet orbiting around it. Or by measuring the slight dip in the brightness of a star when a planet passes in front of it. The discovery of exoplanets has revolutionized our understanding of the universe and the possibility of life beyond Earth. And the search for habitable exoplanets continues to be one of the most exciting and promising areas of astronomy. The search for exoplanets, or planets outside of our solar system, is one of the most exciting fields in astronomy today. But how do we actually detect these distant worlds? One of the most common methods is radial velocity, also known as the Doppler method. This method measures the wobble of a star caused by the gravitational pull of an orbiting planet. The stronger the pull, the larger the wobble, and the larger the planet. The strength of this method is that it can detect planets that are much farther away from their host star than other methods, such as transit. However, it can only detect massive planets that are close to their host star. Another popular method is transit, where we detect a planet by observing the small dip in brightness of a star as a planet passes in front of it. This method allows us to detect smaller planets, but it can only detect planets that are aligned in such a way that they pass in front of their host star as seen from Earth. Finally, there is the direct imaging method, where we take pictures of the planet directly. This method allows us to see the planet and even study its atmosphere, but it is extremely difficult to detect and confirm the existence of a planet using this method. Each method has its own strengths and limitations, but by combining all three methods, we are able to detect a wide variety of exoplanets. The search for exoplanets is ongoing, and who knows what other worlds we will discover in the future. For centuries, humanity has gazed up at the stars and wondered if we are alone in the universe. But in the past few decades, a new frontier in astronomy has emerged, the discovery of exoplanets, planets orbiting stars outside our solar system. The first exoplanet around a Sun-like star was discovered in 1995, orbiting the star 51 Pegasi. This discovery was groundbreaking, as it opened up the possibility for the existence of planets similar to Earth around other stars. But the search for exoplanets continued, and in 2016, a team of scientists announced the discovery of the first exoplanet in the habitable zone, the area around a star where conditions are just right for liquid water to exist on a planet's surface. This exoplanet, named Kepler 186f, is about the same size as Earth and is located about 500 light-years away. And the search for Earth-like exoplanets is ongoing. In 2020, a team of scientists announced the discovery of the most Earth-like exoplanet to date, named TOI 700d. This exoplanet is about the same size as Earth and is located in the habitable zone of its star, about 100 light-years away. These exoplanet discoveries have not only expanded our understanding of the universe, but also raised the possibility of the existence of life beyond Earth. The search for exoplanets continues, and we can expect many more exciting discoveries in the years to come. The discovery of exoplanets has opened up a new frontier in astronomy, but these distant worlds are not easily studied. To understand the atmospheres and surfaces of exoplanets, scientists use a variety of techniques, including spectroscopy and transit photometry. Transit photometry is a method that measures the small dip in a star's brightness that occurs when an exoplanet passes in front of it, or transits. This can reveal the size and orbital period of the exoplanet. Spectroscopy is a technique that breaks down light into its different wavelengths, or colors. By analyzing the light coming from an exoplanet, scientists can determine its composition, temperature, and other properties. By combining these techniques, scientists are able to study the atmospheres of exoplanets in great detail. For example, spectroscopy can be used to detect the presence of gases like water vapor, carbon dioxide, or methane in the atmosphere, which can reveal clues about the planet's potential habitability. With these methods, scientists are able to explore the diversity of exoplanets, from gas giants to rocky planets, and from hot to cold worlds. Each discovery brings us closer to understanding the nature of these distant worlds and the possibility of life beyond our solar system. The discovery of exoplanets has raised the possibility of the existence of life beyond Earth. But how can we detect signs of life, or biosignatures, on these distant worlds? This is the challenge that scientists are currently facing. One approach is to look for biosignatures in the atmospheres of exoplanets. For example, the presence of certain gases like oxygen, methane, or ozone could be indicators of life, as they are not easily produced by non-biological processes. Another approach is to look for biosignatures on the surface of exoplanets, such as signs of vegetation, or even artificial structures. Scientists are exploring the use of new technologies like direct imaging to capture images of exoplanets and search for these surface biosignatures. But detecting biosignatures on exoplanets is not an easy task. The conditions on these worlds can be vastly different from Earth, and false positives are always a possibility. Moreover, the technology we currently have is not advanced enough to detect biosignatures on exoplanets that are very far away. Despite these challenges, the search for biosignatures on exoplanets is a critical step in understanding the nature of life in the universe. Each new discovery brings us one step closer to answering the age-old question of whether we are alone in the cosmos. The search for exoplanets is an ongoing endeavor, and new missions and telescopes are set to take exoplanet research to the next level. One of the most highly anticipated missions is the James Webb Space Telescope, set to launch in 2021. The James Webb Space Telescope, or JWST, is a powerful infrared telescope that will be able to study the atmospheres of exoplanets in great detail. This will enable scientists to search for biosignatures, or signs of life, on exoplanets and to study the diversity of exoplanet atmospheres. Another mission, the Transiting Exoplanet Survey Satellite, or TESS, launched in 2018. TESS uses the transit method to search for exoplanets, and is expected to discover thousands of new exoplanets, including some that are located in the habitable zone of their host stars. These missions, along with other upcoming telescopes such as the European Extremely Large Telescope, are set to revolutionize our understanding of exoplanets. They will enable us to study exoplanets in greater detail than ever before and to search for habitable exoplanets more effectively. The future of exoplanet research is exciting, and we can expect many new discoveries in the years to come. These missions and telescopes will bring us one step closer to answering the question of whether we are alone in the universe. The discovery of exoplanets has opened up a new frontier in astronomy, and the search for habitable exoplanets is at the forefront of this research. In this video, we discussed the methods used to study exoplanets, the search for biosignatures, and the upcoming missions and telescopes that will revolutionize our understanding of these distant worlds. We learned that techniques such as transit photometry and spectroscopy are used to study the atmospheres of exoplanets, and that scientists are searching for biosignatures, or signs of life, on these worlds. We also discussed the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, and other upcoming telescopes that will enable us to study exoplanets in greater detail than ever before. The search for habitable exoplanets is significant because it not only expands our understanding of the universe, but also raises the possibility of the existence of life beyond Earth. Each new discovery brings us one step closer to understanding our place in the cosmos. The search for habitable exoplanets is ongoing, and we can expect many exciting discoveries in the years to come. The future of exoplanet research is bright, and we look forward to uncovering the secrets of these distant worlds.